I am Dr. Dipankar Bhattacharyya.
And I am Dr. Jyotirmoy Guha. Our book entitled Quantum Optics and Quantum Computation, An Introduction, has been published by the Institute of Physics Publishing as IOP book. We have dedicated the book to our teachers Professor Pradip Narayan Ghosh, former Vice Chancellor, Jadavpur University, India, and Professor Padmanabh Dasgupta, former Professor of Physics, University of Kalyani, India. We start with a preliminary discussion on bracket algebra that was introduced by Dirac in chapter 1 and explained the postulates of quantum mechanics in chapter 2. We have compared the ideas of classical and quantum computing and described the journey towards quantum computing, that is Moore's law, in chapter 3. In chapter 4, we introduce quantum bits, the qubits, and then focus on quantum circuits in chapter 5, discussing in the process Bloch sphere, EPR pair, Hadamard basis, plan of a quantum circuit, quantum half adder and quantum full adder. In chapter 6, we discuss teleportation and superdense coding. Pure and mixed states and POVM have been dealt with in chapter 7, and various quantum algorithms discussed in chapter 8 like those of Deutsch, DJ, Bernstein, Vazirani, Simon, Grover and Shor, as well as QFT. Quantum error correction in chapter 9, quantum information in chapter 10, EPR paradox and Bell inequalities in chapter 11, cryptography, the art of coding in chapter 12, and finally some brief comments on experimental aspects of quantum computing in chapter 13. Chapter 14 onwards, we address quantum optics. We discuss the atomic behavior in a resonant electromagnetic field using a semi-classical approach, Rabi oscillation in a two-level atom, broadening mechanism, density matrix, Liouville equation, optical Bloch equations, explanation of lamp dip as well as saturation absorption spectroscopy in chapter 14. In chapter 15, phenomena like coherent population trapping, electromagnetically induced transparency using lambda type 3-level system, interacting with two electromagnetic fields, two-photon detuning and electromagnetically induced absorption have been dealt with. In chapter 16, we present some interesting aspects of coherent light like field quadrature squeezing, while in chapter 17 we derive James-Cumming equation, explain dress state and Rabi flopping using a quantized field and spontaneous emission with Wigner-Weizsäcker formula. In the last chapter 18, we focus on Young's double slit experiment, Hanbury-Brown and Twiss interferometer, and introduce Poissonian as well as super and sub-Poissonian photon distribution statistics and photon bunching and anti-bunching.